Here I'm going to explain how we graph these typical base or parent functions. And I want to go straight to this point right here. That it's perfectly fine for you to forget what these shapes look like. Okay? But what's not okay is to forget how you can come up with their shapes. So, okay, let's say you don't know what square root of x looks like. That's fine. But you cannot forget this part. You have to know that it's possible to graph anything you like using a table of values. And that's where I'm going to start. The square root function. You see, there's no such thing as the square root of a negative number. Forget that. It's not going to work. You could try with your calculator, square root on -1. Your calculator will tell you a math error. Okay, so it doesn't work. So forget about using negative values of x. Let's go straight to x equals 0. Now, some of you might tell me that you don't know the square root of 0, but the square root of 0 is 0. Okay, and f of x, whether it's f of x, g of x, h of x, it doesn't really matter. This just means y. So the y value is root x. When I try to come up with other values of x, you want to think strategically and pick x values that have a nice square root. For example, square root of 1 is 1 because 1 times 1 is 1. If I went to 2, okay, square root of 2, I don't know what answer this is. It's a decimal number, so forget it. Same problem with 3. Square root of 3 is a decimal. So let's go to 4. Square root of 4 is a 2. And the next number that has a nice square root, you have to go all the way to 9. Square root of 9 is a 3. Okay, so I want to plot these points, and that's how I will come up with the shape of the square root function. This is what you need to do when you forget your shapes. So first point, we have x equals 0 with y equals 0. X equals 1 with y equals 1. X equals 4, so I have to go all the way to 4 for the y value to go up to a 2. And then I have to go all the way to a 9, which would be somewhere out here, to get a y value of 3. Okay, this is the square root function. There we go. Okay, so it has a starting point here, and it goes up, but very slowly. Okay, now let's look at b. Y equals 1 over x. Again, it doesn't matter if I call it g of x, h of x, who cares? This just means y. So y equals 1 over x. I'm going to start with some negative values. I'm allowed to do 1 over a negative number. That's perfectly fine. So let's go with -2. 1 over -2, that's just -0.5. 1 over -1 is the next y value, that's -1. So far I have 2 points, -2, -0.5, and -1, -1. Then I'm going to try to do 0. And if you try this with your calculator, try to see what it says when you do 1 over 0. It's going to tell you math error, which means that I can't do it. There's no such thing as 1 over 0. It's an impossible answer. So forget that. I'll then go to a 1. 1 over 1 is a 1. So I have a third point. And then 1 over 2 is the last one that I'm going to plot. Now, you might wonder as to what happened when we went with x equals 0. Why were we not able to get an answer? And what does this mean for your graph? On a graph, if you can't plug in 0 because it makes your denominator 0, you're going to have what we call a vertical asymptote. Okay, the y-axis is also the line that we call x equals 0. So it's a vertical dotted line that your graph cannot cross. But you might also notice that none of the y values we got were equal to 0. If I do 1 over any number I like literally any number, except 0, of course, because I can't, but 1 over any number will never be 0. If you don't believe me, you try it by yourself. Try to do 1 over 20, 1 over 70, 1 over 7, 1 over -4. None of these will ever equal 0. And so that brings us to another asymptote that this graph will have. And it will be at the asymptote of y equals 0, which is the x-axis. Okay, so we've got those two asymptotes right now. And now I'm going to plot the 4 points we got. -2, okay, with -0.5. So very small negative number. -1 with -1. So that's more negative than -0.5. Okay, -0.5. If this is -1, this would be like -0.5. And then, because I have these fences, my graph cannot cross the fences. It's just going to get close to them, but never cross them. And that's a part of this graph. Okay, then I have 1, 1. So x is 1, y is 1. That's right here. X is 2 with y value of 1/2. Half of 1 is here. And again, I can't cross these asymptotes, so the graph just gets close to them, but never crosses them. Okay, so these are those two graphs. And in the next video, I'm going to look at the next couple of graphs so you can see what shape they have.